Pythagoras' theorem, an introduction. Alright, what type of triangle does Pythagoras' theorem refer to? Let's have a look at some triangles and we'll work it out. Pythagoras' theorem will work for that green triangle. Okay, so what type of triangle is that? Let's have a look at another one. This one here, it won't work for that one. Pythagoras' theorem will not work for the pink one. So you might have an idea already. Here comes another triangle. Yes, Pythagoras' theorem will work for that one. Next one. If we have a close look at that one, no, it's not quite going to work for that one. Next one. No, Pythagoras' theorem is not going to work for that one. And we'll give one more example. Yes, Pythagoras' theorem will work for that last one. So there we go, we've got 6 triangles. Let's burn off the ones that it won't work for and focus on the ones that we want to keep. Okay, so here we go. These 3 triangles are a special type of triangle, and Pythagoras' theorem works for this type of triangle. They are all, of course, right-angled triangles. So Pythagoras' theorem works for right-angled triangles. That's the first thing you need to remember about the theorem. Okay, what are the sides called? A triangle has 3 sides, and when we use Pythagoras' theorem, we give them special names. Here's an example of a triangle, and here is one of the names we use. It's just dropped in, the letter C. So that side there has been labelled C. Think about its relationship to the other 2 sides that have not been labelled yet. Let's have a look at another triangle. It's dropped C in, and there's C again on the new triangle. So maybe you're starting to think about what C is and how you could describe that. Let's look at this yellow triangle down the bottom left. Where's C going to drop to? Here we go. Let's see if you can get it right if you're predicting. There it is. And the last one, again, have a think. Where's C going to go? And here it comes. Okay, so C is always the longest side. I wonder how you described it. Some people call it the diagonal. It's actually got a special name, the hypotenuse. But when we're referring to Pythagoras' theorem, we usually refer to it as C. Alright, let's have a look at the other 2 sides now. So that's the long one, C. And the other sides are just called A and B. So we've got A, B, C every time when we're labelling with Pythagoras' theorem. So I wonder how you could describe A and B. If C is the longest, what would you say about A and B? Let's have a look at the other triangles. There's A and B over there on the pink one. Now down to the yellow one. A and B. And across to the green one. A and B. Alright, so how could we describe A and B? Different ways of doing it, I guess, but I'm going to say that A and B are the shorter sides. You may have a different approach which we can discuss. Okay, so C is the longest side, the diagonal. Special name is hypotenuse, and A and B are the shorter sides. Incidentally, it doesn't really matter which one you call A and B. As long as it's either or of the two shorter sides. Okay, what is the rule? So this really is Pythagoras' theorem now. We know that it's for right-angled triangles. We know that it's A, B, and C is the longest side. That's how we label it. But here is the rule. A squared plus B squared equals C squared. That rule you're going to need to remember. So let's have a look at a right-angled triangle. Or actually, let's find out if it is a right-angled triangle, because there's not actually a right angle marked. Okay, let's do some working to test, using Pythagoras' theorem, is this a right-angled triangle? Let's see how the theorem works. So we've got A, B, and C. What numbers or what side lengths are we going to use for A, B, and C? Well, C is often the first one that people identify, and C is that long diagonal, and in this case it's 5 meters. A and B, well, we might call A 3 and B 4, or you could do it the other way around. A could be 4 and B could be 3. But I think we'll go for A 3, B 4, and C 5. So let's put it into the equation now. A is 3, so 3 squared plus 4 squared equals 5 squared. So that's 3 times 3 plus 4 times 4 equals 5 times 5, because we're squaring. Work those out. 9, 16 equals 25. So 25 equals 25. And what that does, that final line there, that proves that this triangle is a right-angled triangle. It worked out nicely at the bottom that 25 was equal to 25. If that long diagonal line C was 6, it would not have been a right-angled triangle, because 3 squared plus 4 squared is 25, but 6 squared, if it was 6, would be 36, and 25 does not equal 36, and therefore a 3, 4, and 6 triangle is not a right-angled triangle. Okay, so that gives you a bit of an idea about how Pythagoras' theorem works. It's for right-angled triangles. A, B, and C are the sides, and we can use it to find out if a triangle is right-angled or not. So in summary, some main points. Pythagoras' theorem only works for right-angled triangles. The long side is called C, or the hypotenuse. The shorter sides are called A and B. And the rule, which you need to remember, is A squared plus B squared equals C squared. So that's a bit of an introduction to Pythagoras' theorem. Bye.